Hello everyone. Today we will look into scientific notation. Scientific notation is a way of expressing numbers that are too big or too small to be conveniently written in decimal form. We also have something called standard notation, which is the numbers as we normally write them. For example, 382 is written in standard notation. First, we will look into converting into scientific notation, then we will convert back to standard form. And if a number is given in standard form, in order to convert it to scientific notation, we are just going to move the decimal point until we have the coefficient, the number between 1 and 10. So if I move the decimal point, we will have 1, 2, 3 times. Once you move the decimal point 3 times, our new number turns into 8.0254. And since we moved the decimal point, we're going to express that movement with powers of 10. So when you have a large number, your exponent will be a positive value, and when you have a small number, you will have a negative exponent. In this case, 0.08 something is a small number, so we are going to have a negative exponent. And here's your try. Here's my next example. This time we are going to try to convert this big number into a scientific notation, and the decimal point on any given number will be at the end of it because it's a whole number, and I will move the decimal point until the remaining number is between 1 and 10. Now 1, 2, 3, 4, 5, 6, 7, 8. If I stop here, our number is 100, and if I go one more, it's 10. So I will go one more in here, and our number will be 1.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 power. Since it's a big number, our exponent is going to be positive. Please try number 2 on your own. Next, we are going to convert a scientific notation number back to standard form. And since we are trying to write the expression back into standard form, we either going to end up with a big number or a small number. And exponent in here tells us that this was a small number because it's a negative exponent. So I know I need to move my decimal point towards left to make this number smaller. And I need to move the decimal point 6 times. 2, 3, 4, 5, 6. Here's the new decimal point, and we will fill the sections with zeros. Our new number is 0.0000. There are 5 zeros in front, and then 4, 9. Get used to putting a 0 up front to make it look prettier. Here's your try. Let's look at a different example. This time we have a positive exponent. When we have a positive exponent, it's an indication that this was a big number. In order to make 7.9 a big number, we will move the decimal point to the right as many times as the exponent tells us. And here is the new location of the decimal point. We will fill in the remaining sections with zeros, and our number will turn into 7, 9, and 0, 0. We have 7,900. Here's your fourth try. Now we get to something more advanced. We're going to multiply two expressions with scientific notation. When we multiply two expressions with scientific notation, we will first multiply the coefficients and then multiply the powers, the tens, by adding their exponents. Then we're going to convert the final result back to scientific notation. So if I multiply my coefficients first, we will get 9 times 3, 27. And I will multiply the tens, 10 to the first power and 10 to the 10 to the negative first power and 10 to the 10th power. I will add the exponents in multiplication. It will turn into 10 to the 9th power. Now 27 is not in scientific notation, it's too big. So we are going to move the decimal point one place to make it a smaller number. And I have 2.7 times 10 to the first power just from 227. And I already had 10 to the 9th power, so we're just going to simplify this one more step. 2.7 times 10 to the 10th power will be our answer. Here's your you try. Multiply your coefficients first and the tens. Convert the coefficient only back to scientific notation, and then add your exponents. Here's my next example of multiplication. My process is multiply the coefficients, 30, multiply the tens, 10 to the 8th power, 10 to the negative 2nd power, which will add up to 10 to the positive 6th power. Now this answer is not in scientific notation. We will first convert 30 back to scientific notation. This will be 3 times 10 to the first power, because the big number, it will give you positive exponent. Move the decimal point once to the left. I still have 10 to the 6th power. We will now multiply the tens together, which means we will add the exponents. 1 plus 6 is 7. Here's your you try number 6. Here's our next example. This time I will multiply a whole number with a scientific notation. When I multiply a whole number with a scientific notation, I will only multiply the whole number with the coefficient of the scientific notation. 5 times 32, 3.2, will be 16. And we still have times 10 to the 6th power. 16 is not in scientific notation, so I'll have to convert this back to scientific notation. It's a big number, so it will become 1.6 times 10 to the first power. And I have 10 to the 6th power already. And we will multiply the tens together. 1.6 times 10 to the 7th power. Here's your you try 7. Next, we are going to look into dividing with scientific notation. When we divide scientific notation, we will first divide the coefficients and then divide the powers of tens. And finally, we will convert the answer back to scientific notation. Let's do the division problem first. 3.5 times 10 to the negative 6 divided by 5 times 10 to the negative 2nd power. If I divide the coefficients, we will get 0.7. If I divide the exponents, negative 6 and negative 2 on the denominator, the exponents will become 10 to the negative 4th power. Now 0.7 is not a scientific notation, and it's a small number, so if I convert this back to scientific notation, this will be 7 times 10 to the negative 1st power. We already have 10 to the negative 4th power, so our result would be 7 times 10 to the negative 5th power. And here's your you try. My next example, I will divide the coefficients first and then take care of the exponent parts. 2.6 divided by 6.5 is 0.4. And 10 to the 6th power divided by 10 to the negative 2nd power will be 10 to the 8th power. 0.4 is not in scientific notation, and it's a small number, so if I convert it back to scientific notation, we will get 4 times 10 to the negative 1st power, and we already have 10 to the 8th power. We will add the exponents in multiplication when bases are same, so you have 4 times 10 to the 7th power as your final answer. Please try number 9. Let's look at our next example. 7.5 times 10 to the 6th and 8.2 times 10 to the first power. If I do the division with the coefficients, I'll get 0.8658536585. And we still have the tens part to divide, and if I have 10 to the 6th power divided by 10 to the first power, we'll have 10 to the 5th power. Now, this number is a small number, and we need to convert it back to decimal. In order to convert it back to decimal, we're going to move the decimal point, convert to standard form. We will move the decimal point one place to the right, and problem will turn into 8.6585365585 times 10 to the, because it was a small number, this is going to be 10 to the negative first power, and we already have 10 to the 5th power on hand. And all we have to do is to add the exponents on the tens, and remaining of the number will stay the same. 8.658536585 times 10 to the 4th power. This will be our answer in scientific notation. Please try number 10. Our next topic is exponents with scientific notation. When we have an exponent covering the entire scientific notation expression, everything inside of the parenthesis will be affected by the exponent. So we will apply the exponent onto the number part and the 10 part of the scientific notation. We will then convert the result back into scientific notation. So if I apply the exponent onto number part and the tens part, we will have 8.9 to the 4th power times 10 to the 5th power to the 4th power. Now, hopefully this will be familiar to you as power to power property, where we would multiply the exponents, and then I can write 10 to the 20th power. 8.9 to the 4th power is something we can put on the calculator, and we will have 6274.2241. And the coefficient part is not in scientific notation, and it's a big number. We will convert it to scientific notation by moving our decimal point until the number is between 1 and 10. Our number will turn into 6.2742241 times, because we moved 3 times and it was a big number, we have positive exponent on the 10, and we already have 10 to the 20th power, and all we have to do is to add the exponent in multiplication when bases are same. I have 6.2742241 times 10 to the 23rd power as my answer. Please try the next one on your own. Here's my next example. Just like earlier, we're going to apply the exponent onto both of them. And this will be 4 to the negative 6th power times 10 to the negative 5th to the negative 6th power. Power to power property, apply that. We will have 10 to the 30th power. And we are going to evaluate 4 to the negative 6th power. Whenever we are trying to calculate 4 to the negative 6th power, we're going to use the exponent button on the calculator. Go ahead and put the 4, and then exponent button is the hat shape button under clear. So we will raise to the power, and in this case we are raising to the power of negative 6, and you should see that on your screen as well. And when you hit enter, you should get your answer. When we put this value into the calculator, it was so small of a decimal value and it didn't fit on the screen properly. Therefore, calculator automatically converted this number into scientific notation. The E on the calculator at the end of the expression tells us that this is the exponent of -4. So when we write this into scientific notation, we will write this as with the new exponent with the e -4 refers to exponent 10 to the -4. So we write that part as is directly from the calculator. We will then continue with our regular steps. Since the number part, coefficient part is already written in scientific notation for us, so I don't have to do anything to it. All I have to do is to add the exponents on the tens. So we will have 10 to the 26th power as our answer. Please try the next one on your own. Here's my next example. This time I'm going to apply the exponents again on both of them separately. I have 5.21 to the second power times I have 10 to the -5th to the second power. First one I can easily put in the calculator, and we will have 27.1441, and the second part, the exponent part, is going to have power to power property, which will be 10 to the -10th power. And 27 is a big number. It's not in scientific notation, so I will move my decimal point once. It will become 2.71441 times 10 to the positive first power, because this was a big number. I still have my 10 to the -10 power. I will just add the exponent on those. 2.71441 times 10 to the -9th power. Please try next question on your own. This is pretty much it. Let me tell you a joke too. What does the cat sound like? This would be a better joke for our statistics unit. The cat makes mew sound.